Hello you all. Let me welcome you to my channel TK Bansal. In 30 years of my teaching experience, I have found that physics is a nightmare for most of the students. Whereas physics is one of the most interesting and beautiful subject, and you once prepare it, you will never forget it. If you also find physics to be a nightmare, then do comment in the comment box. It is my mission to spread physics and make the life of the students wonderful. Before going further, please do press the subscribe button and don't forget to press the bell icon to get the notifications of all my future videos. Now let us go to the next question in this session on solutions to JEE Main 2018 Physics. The question is, for an RLC circuit driven with a voltage of amplitude Vm and frequency omega naught equal to 1 by root of LC, the current exhibits resonance. The quality factor Q of this circuit is given by. The choices are RC divided by omega naught L divided by R, omega naught R divided by L, and R divided by omega naught C. This is a very simple formula based question from AC circuits. We know that for a LCR circuit, the quality factor is defined as the ratio of the full width at half maximum divided by the resonance frequency, or Q is equal to delta omega divided by omega naught, which is calculated as Q is equal to 1 by R into root of L by C. If we multiply the numerator and denominator by L, we get Q is equal to 1 by R into root of L square divided by LC, which on substituting 1 by LC is equal to omega naught square, we get Q is equal to omega naught L divided by R. So this is our right answer, which matches with the second choice of our four choices. Alternatively, I can solve this question with the help of dimensions, and if we examine the dimensions of each of the four choices, we find that only the second choice, that is L omega naught divided by R, is dimensionless, and all other choices are having dimensions, whereas quality factor Q is also dimensionless. Therefore second one is the right choice. My next question is, in a collinear collision, a particle with initial speed v0 strikes a stationary particle of the same mass. If the final kinetic energy is 50% greater than the original kinetic energy, the magnitude of the relative velocity between the two particles after the collision is. The choices are v0 divided by root 2, v0 divided by 4, root 2 times of v0, and v0 divided by 2. So before we go any further, let's have a look at this video clip. In this video clip, all the three collisions shown are elastic, whereas in our problem, the collision is inelastic. So how to solve this problem? Please note, in every collision, elastic or inelastic, momentum is always conserved. Please note, most of the students start with kinetic energy conservation, which is wrong. So we must always start with momentum conservation. Using momentum conservation, we get m times of v0 is equal to m times of v1 plus m times of v2, which on simplification gives me v0 is equal to v1 plus v2, equation number 1. Secondly, the final kinetic energy is equal to 1.5 times of initial kinetic energy, that is half m v1 square plus half m v2 square is equal to 1.5 times of half m v0 square. On simplification, we get V1 square plus V2 square is equal to 1.5 times of V naught square. That is equation number 2. Now squaring equation 1, we get V1 square plus V2 square plus twice of V1 V2 is equal to V naught square, or twice of V1 V2 is equal to V naught square is equal to V naught square minus 1.5 V naught square, or twice of V1 V2 is equal to minus of 0.5 V naught square. Now at the final step, we get V2 minus V1 is equal to square root of V1 square plus V2 square minus twice of V1 V2. Substituting the values, we get V2 minus V1 is equal to root 2 times of V naught, and that is my final answer, which matches with the third choice in the given problem, and hence that is my right answer. My next question is, a particle is moving with a uniform speed in a circular orbit of radius r in a central force which is inversely proportional to the nth power of r. If the period of this rotation is t, then the t is proportional to. My choices are r raised to power n by 2, r raised to power 3 by 2 for any value of n, r raised to power n by 2 plus 1, and r raised to power n plus 1 divided by 2. Now let us try to understand the problem. In this problem, the particle is moving with a constant speed v in a circular motion. Although the speed of the particle is a constant, but its direction is changing at every moment of time, and hence its velocity is changing, and therefore the particle possesses an acceleration, and we call this acceleration as the centripetal acceleration. This acceleration is provided by a force that is known as the centripetal force. It's important to note that centripetal force is not a force by itself, and it has to be provided by some other real forces which we will discuss in a later video. But in the present problem, the centripetal force is provided by the central force F. So we can say that mv square by r is equal to F, or mv square by r is equal to k divided by r raised to power n. On simplification, we get v is equal to square root of k divided by m into r raised to power n minus 1. Now, the time period of rotation, t is given by t is equal to 2 pi r divided by v, which is equal to 2 pi r divided by square root of k divided by m into r raised to power n minus 1. On simplification, we get t is proportional to r raised to power n plus 1 divided by 2, which matches with the fourth choice of the given choices, and hence the fourth choice is the right answer. Our next question is, two batteries with EMF 12 volt and 13 volt are connected in parallel across a load resistance of 10 ohm. The internal resistances of the batteries are 1 ohm and 2 ohm respectively. The voltage across the load lies between. The choices are 11.7 volts and 11.8 volts, 11.6 volts and 11.7 volts, 11.5 volts and 11.6 volts, and 11.4 volts and 11.5 volts. This is a problem based on finding the equivalent EMF of a parallel combination of cells. We may redraw the given circuit having 3 cells in parallel, one of EMF 12 volts and internal resistance equal to 1 ohm, the second of EMF 13 volts and internal resistance 2 ohms, and the third one of EMF 0 volts and EMF 10 ohms. And using the formula that the equivalent EMF is equal to summation of EI divided by RI and whole divided by summation of 1 by RI, and I get equivalent EMF is equal to 12 by 1 plus 13 by 2 plus 0 by 10 whole divided by 1 by 1 plus 1 by 2 plus 1 by 10, which on simplification gives me E equivalent is equal to 18.5 divided by 16 divided by 10, or E equivalent is equal to 185 divided by 16, which is calculated as E equivalent is equal to 11.56 volts. Alternative solution. Let us assume that we forget the formula, which we will obviously do. Then what we should do? We will solve this question with the help of Kirchhoff's laws. Let the battery of EMF 12 volts supply a current of I1, whereas that of EMF 13 volts supply a current of I2. Then the two currents I1 plus I2 will pass through the load resistance of 10 ohms. And applying the Kirchhoff's loop rules, we get 12 is equal to I1 plus I2 into 10, equation 1, and 13 is equal to 2 times of I2 plus I1 plus I2 into 10, equation number 2. Dividing the second equation by 2 and adding it to equation 1, we get 12 plus 6.5 is equal to I1 plus I2 into 10 plus 5 plus 1, or 18.5 is equal to I1 plus I2 into 16, or I1 plus I2 is equal to 18.5 divided by 16 amperes. Now the voltage across the load resistance of 10 ohms is I1 plus I2 into R, which is I1 plus I2 into 10, which gives me 185 divided by 16, which on simplification gives me 11.56 volts. Now very clearly this lies between 11.5 volts and 11.6 volts. Therefore the choice third is correct. Now let me go to the next question. In an AC circuit, the instantaneous EMF and current are E is equal to 100 sine 30t volts and I is equal to 20 sine 30t minus pi by 4 amperes. In one cycle of AC, the average power consumed by the circuit and the wattless current are respectively. The choices are 50 watt and 0 amperes, 50 watt and 10 amperes, 1000 by root 2 watt and 10 amperes, 50 root 2 watts and 0 amperes. This is a very simple question from AC circuits. It is given that the EMF E is equal to 100 sine 30t volts and the current is I is equal to 20 sine 30t minus pi by 4, where E maximum is equal to 100 volts, I maximum is equal to 20 amperes, and delta phi, the phase difference, is equal to pi by 4. The average power is given by IRMS into VRMS into cos of delta phi. On substituting, we get average power is equal to 100 into 20 divided by 2 into cos of pi by 4, which on simplification gives me 1000 divided by root 2 watts. Now let us find out the wattless current. The phasor diagram right, you can see that the current is at an angle of 45 degrees to the voltage, and the wattless current is a component of the RMS current in a direction perpendicular to the EMF. So I get the wattless current I is equal to IRMS into sine of delta phi, which is equal to 20 divided by root 2 into sine of pi by 4, which is equal to 10 amperes. Answer is 1000 divided by root 2 watts and 10 amperes, which matches with the third choice of the four given choices, and therefore the third choice is the right answer. The next question is, an EM wave from air enters a medium. The electric fields are E1 vector is equal to E01 x cap into cos of bracket starts 2 pi nu into z by c minus t bracket closed in air, and E2 vector is equal to E02 into x cap into cos of bracket starts k into 2z minus ct bracket closed in the medium, where the wave number k and the frequency nu are their values in the air. The medium is non-magnetic if epsilon r1 and epsilon r2 are the relative permittivity of the air and medium respectively. The correct choice is epsilon r1 divided by epsilon r2 is equal to 1 by 2. Epsilon r1 divided by epsilon r2 is equal to 4. Epsilon r1 divided by epsilon r2 is equal to 2, and epsilon r1 divided by epsilon r2 is equal to 1 by 4. Now let us try to understand the problem. This is a question from electromagnetic waves. From the general forms of the equations of a wave, that is y is equal to a sine of omega t minus kx, comma y is equal to a sine of omega bracket starts t minus x by c bracket closed, and y is equal to a sine k into ct minus x bracket close. It can be seen that when the coefficient of t is 1, then the coefficient of x is 1 by speed of light, whereas when the coefficient of x is 1, then the coefficient of t is c, the speed of the wave. So from these equations it is clear that as per equation 1, which is E1 vector is equal to E01 into x cap into cos of 2 pi nu into z divided by c minus of t, the speed of the wave comes out to be equal to c. Whereas if we take c out from the second equation, we get E2 vector is equal to E02 into x cap into cos of 2 pi nu bracket starts 2 by c z minus t, tells you that the speed of the wave in the medium is c by 2. Also we know that the refractive index n of a medium is given by speed of the wave in vacuum divided by speed of the wave in medium, which in this case is equal to c divided by c by 2, which comes out to be equal to. Also we know that the refractive index of a medium n is given by square root of mu naught into epsilon naught into mu r2 into epsilon r2 whole divided by mu naught into epsilon naught into mu r1 into epsilon r1. Since the medium is non-magnetic, therefore mu r1 is equal to mu r2 is equal to 1. On simplifying, we get n is equal to square root of epsilon r2 divided by epsilon r1, which is equal to 2, or squaring we get epsilon r1 divided by epsilon r2 is equal to 1 by 4. which matches with choice number 4, and hence fourth is the right choice. I hope you enjoyed this video. In case you have any difficulties, please write to me in the comment box. Don't forget to comment, share, like and subscribe this channel, and visit us again for the next video. Till then, happy learning.